B is higher frequency. So this is higher frequency. A has lower frequency. How do we measure frequency? Frequency is the number of cycles per second, or number of cycles within a given period of time. You can see that here I have many cycles within a specified time compared to what I have here. So if I repeat, let's say the second one, something like this. So C, and let's talk about D here. I think now you see it better. Yes. So C is lower frequency, D is higher frequency again. Now, what about wavelength? C has longer wavelength while D has shorter wavelength. What is the wavelength? Wavelength is the distance between these two peaks or two crests or troughs. So this is one wavelength, this is also one wavelength. So the distance between either two peaks or two troughs or crests, that is called wavelength. The smaller or the higher the frequency, you can see the distance is very short between the peaks. Here, because we have lower frequency, the distance between the peaks is higher. So here we have, on the left hand side, we have higher wavelength. On the right hand side, we have higher frequency. That is how you can basically, in a simple, simplistic way, differentiate between frequency and wavelength of a wave. As you can see, the distance here from the rest center position, this distance is smaller on E as compared to the distance that we have on F. This distance here, we have a larger distance on F as compared to the distance on E. That means we have a higher amplitude on F while we have a lower amplitude on E. That is also another property of light that is very important for us to understand. Why? Because the amplitude is related to intensity. So if you say this light has high intensity, high illumination, it corresponds to higher amplitude. So these are amplitudes. This is amplitude. Yeah. So if you have higher intensity, it means you have high amplitude, because amplitude, let's say if intensity is the square of amplitude. Another property or characteristic of light that is very important for us to understand is what? Velocity. What about velocity? Velocity is also determined, or you can talk about it as speed, like this. So the faster, if you are moving from left to right, the faster the wave is actually traveling, the faster it is moving from left to right, the faster it's moving. That is high velocity. The lesser, if we have another one, which let's say is here, it means this wave here, if you compared it to this wave here, this wave is faster compared to this wave in terms of if you consider them in a horizontal plane. This one is below, this one is in front. Okay, that is very important for us to understand these two, this and this. So energy of light wave is equal to hf. H is a constant usually. It's a mathematical constant which is a value. But F is frequency. That's why in the part of electromagnetic spectrum, you see when we have higher frequency, when frequency increases, energy also increases. Why? Because energy is directly proportional to frequency. That is important for us to understand. So frequency determines the energy of electromagnetic wave. It determines the energy of light. What about wavelength? Wavelength Wavelength is very important because it determines color of light. Wavelength is very important because it determines the color of light. So when we have red, we have green, we have blue, these different colors have different wavelengths. Like red, you'll find something around, let's say, 700 nanometers. Green, you'll find something around, let's say, 500 nanometers. And blue, you'll find probably something around 400 nanometers. So when you talk about wavelength of light, it determines the color of that light.